Welcome. This lesson is just a continuation from the last one, except now we're going to tell whether it's consistent or inconsistent, dependent or independent without graphing it. It's very, very simple how to do. What you're first going to do, and like I said, I always like to start with the dependent and the independent. Is it the same equation or is it not the same equation? Well, these two are definitely not the same equation. If it's not the same equation, then it's going to not be dependent, because for it to be dependent, it has to be the same equation. Now that I've got rid of that one, now I got to decide whether it's consistent or inconsistent. Consistent means that they cross. They eventually intersect at some point, or it's the same line. Inconsistent means they're parallel. Well, these have different slopes, totally different slopes. If it's different slopes, then it's consistent. So these would be consistent and independent. So again, first thing I do is it the exact same equation? 8/5 x, 8/5 x, minus 6, minus, 8/3. Oh, different equations. Different. It's not dependent. I can scratch out this one. I know it's not that one. Okay. Now I got to decide, are they parallel or do they intersect? Well, they're parallel and they never intersect because they have a different y-intercept. Since they never intersect or they're parallel, it's inconsistent. Inconsistent, because remember, consistent means they're eventually going to cross at some point. So this one's consistent. Now, eventually you're going to get to some equations that are not written in slope-intercept form. So that's what you'll have to do. You'll have to write them in slope-intercept form. And again, with practice, it becomes fairly simple. All you're going to do is I'm going to minus the 7x over. So I have that 10y equals, again, minus 7x, because when I bring it over, it changes the sign. And then I have a plus 6. And then I got one more step to do, and that's to divide everything by 10. So my final equation in slope-intercept form would be a negative 7 divided by 10 x, because that's this 7 divided by 10, because I'm dividing this by 10, I'm dividing this by 10, and I'm dividing this by 10. So then I get a plus 3/5 because I reduce. So there's the top equation written in the form of y equals mx plus b. Mx plus b. Now let's do the bottom equation. First thing I'm going to do is minus 11x over. So I'm left with a negative 18y equals a negative 11x minus 5. It's a horrible 11. Negative 11x. Okay, so that's just bringing this 11x over. Changes sign. Now I'm going to divide everything by negative 18. Right? Divide by negative 18. Divide by negative 18. Again, that leaves me a y equals. Now a negative divided by a negative is positive, and that's an 11, not a 14. It looks kind of like a 14. And it's going to be an 11 over 18, because that does not reduce. X. And then a minus over a minus is a plus. 5 over 18, again, does not reduce. Now, is it the same line? Is this equation the exact same as this equation? No, they're not. So they're not dependent. They'll either be consistent and independent or inconsistent. Now I look to see if it has the same slope. Are they parallel? Are they parallel? No, they're not parallel. They're eventually going to cross. That means they're consistent, not inconsistent. So I found out this one is consistent and independent. Again, if you have questions, please bring them to class and I will clarify. Just remember, dependent means it has to be the same equation. So when you reduce this to y equals mx plus b, they look exactly the same. If they don't look exactly the same, then they're either parallel, and parallel means they're inconsistent, or they're not parallel, they intersect at some point, and that means they're consistent but independent.